Hi, I'm Chris Kirkman with aetutsplus.com, and in this tutorial we'll be looking at how to create complex visual patterns with a relatively simple expression controlled by sliders tied into Particular 2.0. Now, as a kid you might remember the Spirograph, the little templated toy where you have one circle in the gear of another circle and you stick your pencil in a hole and draw these complex circular repeating patterns. Well, this is basically just that. In the mathematical world, these shapes are called hypotrochoids and endotrochoids. I think I'm pronouncing that correctly. I'm not a mathematician, so we'll do what we can. An example would be right here on the screen. So what you're looking at is essentially a pen made up of particles drawing on the screen these complex and slightly offset lines. These visual patterns are pretty intricate and cool to look at, and there's a lot of things you can do with Particular in order to enhance these. We're going to stick with just how to create the simple shapes, and I think you'll enjoy it. I want to get a quick shout out to Dan Eberts. Dan is a motion scripting expert. You can find his website at www.motionscript.com. There's lots of other formulas there, lots of motion scripting scripts that you can apply to your own projects. He helped me in this case with some of the scaling, and he did a similar version of this tutorial, or a application I should say, to the Write-On plugin for After Effects to create these same shapes. In my case, I'm doing them in 3D space with Trapcode Particular, and let's take a look at it now. Thanks again, Dan. Okay, let's start off with a new project and a new comp. I'll call this new comp Spyro. And to avoid any legal complications, you won't hear me say the name Spirograph from here on out. Okay, 720 by 480 is our NTSC DV. That's basically default. Make your comp 20 seconds. That way we have enough time for the pen to work its way around and actually start creating these shapes, these weavings, these webbings that we want to produce. Click OK. And in your Spyro comp, I'm going to create a new null. Click on your null. We're going to name that Spyro controller. All right. Now the first thing that we need to do is apply sliders that are going to control how this effect works. So in your effects control panel, you can either go up to Effect, Expression Controls, Slider Control, which will put one in there, or if you go to your Effects and Presets panel over here, you can just type in Slider, and if you spell it correctly, you'll see Slider, and you can just drag and drop. Now click on your new slider control and hit enter to rename. We're going to call this fixed radius. And we're going to set the value. This is just for our own purposes. The numbers can be anything, but the slider to dragging back and forth, we want it to stay within a particular constraint, and that's going to go for all the variables we're creating. For this one, let's just do 0 and 500. Okay. Click on your fixed radius and duplicate, Command D or Control D, depending on if you're a PC or Mac person. Hit enter to rename, and we're going to call this moving radius. Okay. Duplicate one more time. Call this point offset. I'll explain a little bit about what these are. Go back real quickly. We're going to edit the value of the moving radius. This one's going to be slightly different. We're going to go into the negative range here, negative 100 to positive 100. And for our point offset, we're going to make this negative 50 to positive 50. And those are the very basic controls for this shape or this formula. The fixed radius is the large circle. If you remember the toy as a kid, you'll probably remember there was the template was just basically a hole in a piece of plastic with little gear teeth. and then what you chose from your little palette of shapes were these other little pieces of plastic, usually in a circle format with different amounts of teeth around the outer edge, or sometimes it was a triangle or like a rounded square, something along those lines that the teeth fit into that went around the inside of the circle. And then inside of that plastic shape were holes to place your pencil. And you basically, move your pencil in a circle, and it would follow the shape of the outer circle along the constraints with the inner shape, the inner circle with the amount of gears, however size it was. And you had different holes that you could stick the pencil into. So fixed radius, large circle; moving radius, smaller circle that actually moves around; and the point offset, which is where you'd place your pen. Okay. Now we need two additional variables here. The first one is the speed variable, and this allows us to control how fast the pen is moving on the paper. So let's duplicate the point offset, and we're going to call this speed. And this should stay at a relatively low number because it's a multiplier. So we're going to do edit value, and slider range 0 to, let's just say 10 for now. That's probably more than enough. Duplicate your speed value, and this is going to be your scale value. Okay, and same thing here, edit your value. You want the scale to be 1 to probably no more than 5. All right. As I mentioned, the speed controls how fast the pen moves along that circle. In the scale case, let's say you get a neat shape, looks like your grandmother's doilies, and but it's very small on the screen, and you want to scale that up. Now, it would be really kind of difficult to change your fixed radius and change your moving radius and change your point offset to retain that same shape, only on a larger scale to fill up more of your screen. That's why we add the scale property. This allows us to scale up or down as a whole rather than trying to recreate that shape just on a larger scale with the other two radiuses. Okay. Now that we have our variables, we can move on to something a little more fun, and that's our particles. So we're going to add a new solid. Make sure you hit make comp size, be whatever name color you want it. I usually keep mine gray, and just to let me know that it's I use this as a tool as opposed to a color layer of some sort. Okay, I'm just going to drag this below the controller, and I'm going to call it particles. Straightforward. Now we're going to apply particular. In this case, I'm going to use my effects and presets panel. I'm going to type in particular and spell it correctly. There we go. Particular, drag and drop. And if you scrub here, you're going to see your basic point cloud, your blast of particles, water spraying right at you, what have you. Pretty boring. Now what we're going to modify in order to make these shapes is the XY position of the emitter of the particle layer. So let's rotate down or twirl down your emitter, and you'll see position XY. Okay, that's where we're going to be applying this super formula. Hold the Alt or the Command key on your Macintosh and click on the stopwatch for position XY. Okay, and that opens up down here your expression panel, your area for the formula. We have to create the variables that are going to be used for this shape generator, and we have to tie them into our controller. That's really easy to do using the pick whip, but I'll explain what's going on as we go forward. Once the formula has been typed in its entirety, I would just suggest using your pause button so that you can get exactly what it says on the screen, and double check that the formula is correct, because even a missed parenthesis or a bad minus sign or something will throw this all off. So let's start by adding the fixed radius. We'll call it FR equals. And then we're going to, I should have done this before, ignore that error for the moment. Twirl down, or just select your spiral controller and hit E for effects. And you're going to want to see all the sliders. So select all these and twirl down 1, which will twirl all of them down so you can see the slider values for each one of these. Okay. Go back to your position XY. And I'm going to shrink this up a little bit so we can see it all. And we're back to the fixed radius. Yes, I know, thank you. Fixed radius equals. Grab your pick whip and drag it until you see the slider and right over the top of fixed radius. And it immediately fills everything in for you, which is real handy because it's a lot of typing. Go down to your next line. We're going to do the same thing for moving radius. So MR equals pick whip. Find your moving radius slider. Done there. And now our offset, we'll just call O for offset. Scroll up, find your point offset slider. Boom. Next one down, this is our speed. Speed's just a hint different. Again, SP equals, and you're going to find up your speed slider. Now speed is a function of time. So we have to multiply that value by the time of your comp. And this is what causes it to actually be drawn over time. That's all we need there. Hit enter, and now your scale, we'll call it SC equals, grab your pick whip, and up to slider. Okay. And we're done with the variables, the primary variables. But there is a little hitch in this, and that's that when the fixed radius or the moving radius, the multiplication and the division and all the stuff that's going to happen in a moment with the next couple of lines, if it ever hits a point that in mathematics is called a non-zero value, it causes it to break. You'll get errors. And when you're sliding up and down to get the right shape, it's kind of annoying because you'll accidentally cross over 0 at any given point and it'll pop up that error, and then you have to reset the formula. So in order to avoid that entirely, we're going to add a couple of if statements. If moving radius is equal to, that's two equal signs, 0, close parentheses there, then immediately set moving radius to 1. So if at any time it hits 0, ignore the 0 and immediately go to 1. Pretty straightforward. I'm going to do the same thing for the fixed radius. If parentheses fixed radius is equal to 0, close parentheses, fixed radius equals 1. So that's just a little, error prevention for the future. Now here comes the big part. This is a long line of code, but this is what actually creates the shapes on the screen by doing complex mathematical computations. The x value, x equals fixed radius plus moving radius times math.cosine times, or in this case it's in parentheses, the speed minus, parenthesis, moving radius plus offset, parentheses, times math dot cosine. Now there are three open parens here, 1, 2, 3, fixed radius plus moving radius, close parenthesis 1, divided by moving radius, close parenthesis 2, times speed, close parenthesis 3. That's a lot. I know. Oops. Fortunately, to get the y, all we need to do is copy and paste this. Change the y, the x to y, and change cosine to sine. Now, some of you math heads out there might know what's going on here. I honestly don't. This formula has been around for ages. Dates back to probably Greek mathematicians, beyond my knowledge, all calculus. But I know that it works, and I know that it's cool. So now that we have those two variables being generated, all we have to do is apply them to the x and y position of the emitter directly. Before we do that, though, this is based. The formula is based on a 0, 0 center, and After Effects doesn't quite work like that. So we need to get the center point of our comp and add that to the 0, 0 values that are created from this formula. So we do that by doing bracket this comp dot width divided by 2, so getting half of the width. I'll spell width correct there. Okay, and then this comp dot height divided by 2, so the center in the up and down now. Add that to the x and y values that we just got, and then a quick multiplication by the scale And this is what we talked about before, where we can take everything and make it bigger without having to modify the shape at all. That's it. Apparently not. Let's see, line 11. Where's the error here? Rookie mistake. Keep in mind that when you're doing expressions, you need to make sure you put your semicolons in. So I've gone ahead and done that real quickly, and that should solve the problem. Okay, now I'm going to close up this just to kind of clean things up just a little bit. And if we scrub through our timeline, nothing. And there's a good reason for that. All of our values in our Spiro controller here are set to 0. And that being said, let's add some values. First thing, scale, got to be at least 1, 1 for 1. Speed, same thing. If it's not moving, it's not going to do anything. Now, in your fixed radius, in my example that I showed earlier, the fixed radius is 181. Now, by itself, we should now start to see, yes, the emitter is moving in a circle. And that's it, really. It's a perfect circle. And that's okay, because we haven't added an inner circle for it to go around. So assuming that inner circle has a 0, all we're doing is tracing the inside of that first fixed circle. Which is okay. Sure, you can create a circle, no big deal. Let's get a little fancier though. Again, back to my original example. The moving radius was at 58. And if we do that, now we start to see that if the circle is now moving, it's also traveling in a circle. The pen's still not offset, but that's okay. We're seeing like some humps as it's going around a circle, like flower petals around the center of a flower. Okay, finishing off from where I had it, point offset in my original example was 7. I jumped the speed up just a little bit to 3, and the slider on the scale remains at 0. So now what you're seeing, there's a lot of stuff going on here, and it's hard to see exactly what's going on, but you can kind of imagine it as a little bit of a 4-leaf clover. Problem is that the particles are going everywhere. So the next step in this process is to get those particles down to something a little more manageable. Stop their velocity, stop them from traveling off on their own to make them look like more of a line being drawn. Or tighten them up depending on how your particular project needs them. So clicking back over to our particles layer, I'm going to up the particles here to 300, just to give them a little more thickness. And the most important part, we're going to drop the velocity in every aspect here down to 0. And immediately what you start to see is that things are coming right together. When the particles aren't flying off on their own, you start to see those lines being drawn. Now, you don't really get the effect here because the lines aren't staying on long enough. In this case, the particle life is a little too quick. And by default, particle life is set to 3 seconds. So we're going to jump that up. Go under particle. And up here where it says life, let's change that to the life of our comp, which is 20 seconds. And now we're going to start to see some real complex patterns. It's the same pattern being looped over and over again, but it creates this webbing that has a real nice kind of look to it. I'm also going to drop the size of the particles down to about, let's say 2. You start to see the dots in here, and that's all right. We're going to scale this down. It's a little bit big. We can do that one of 2 ways. We can either go back to the Spiro controller, and we can change this scale slider, let's say to 0.5. That'll keep the shape, and that'll really smoothen the transition of the separation between the particles out. Looks like a much thicker line. If we didn't do that, let's go back to 1 here. We can also do the speed. Now, when we change the speed, you'll notice if I go back down to 1, things will tighten up considerably, but you won't have as many iterations of that shape. It does create a much smoother looking shape, but you don't get layer upon layer. The other way we can do that is we can try and adjust the fixed radius and the moving radius to keep that same basic percentage. This is based on a percentage, so if we kept that same ratio, we could get that. But that's really complicated, and we don't want to get into that. So for the moment, let's just let's take the speed back up to, let's say 2. We'll compromise here, And we're going to take the slider for scale down to half. There we go. That's pretty good. We're getting a lot of overlapping shapes, and it gives us something to play with. Now that we have and we know that the formula is working, we can make all kinds of changes. We can scale this up. Scale this up. That's interesting. We can even go into negatives here. Let's go to negative 50. And things get a little more angular here in the negatives, because now you're outside of that circle instead of inside of that circle. And you can kind of tell if you look at these rounded edges here, you can kind of imagine that as your smaller circle, your moving radius being outside, and that's the curve of that. The more we increase this, the wider that will be. I say increase, I should mean decrease in the negative, but you can see that the value of that circle would be getting pretty wide here. That's how you get your stars, more angular shapes. Let's bring this back down, say negative 5. Ooh, that's negative 50. We've already been there. Negative 5. Now we're getting more of a circle because we're closer to that 0 point in all the situations here. I'm going to bring our fixed radius way down. And then you can play with the offset. You can really jack it up to get these more contained shapes. Bottom line is just play with it. That sounds dirty. Experiment. How's that? You can get flower shapes, star shapes. I've gotten these 3-point, I don't know what to call them, 3-point ovals, maybe. Let's try like 43. That's interesting. Negative 14. There we go. 53. Yeah, we'll get some of that. And let's scale it up too so that we can kind of see the shape better. That's really interesting. So now that you got your shape the way you want it, you can go back to your particles and change all kinds of stuff. Change the size, obviously, the type of shape that appears. Maybe we wanted a star. That's a little much. Or I would just change the color. We can do color over life, and we get our default colors here, rainbow colors. I like with my example, I did something to this effect. I'll just choose a red here, keep the yellow, make this a white. That'll be our pen tip. Really bring it in close. And maybe make this a little darker so it looks like it's fading off into something or into nothingness. So some really, really nice shapes here that change over time. You can also try animating the controls over time. You might see some jerkiness in that just because it's suddenly changing its shape, but you can get some interesting dynamic effects by doing that. But bottom line is experiment, and now you've got your own little virtual spiral. Check that, your own virtual hypertrochoid or endotrochoid generator in After Effects. So have fun with that. If you come up with any interesting ways to use this, certainly let us know. Post a comment in the section below. Also, come visit me. I'm over at the Motion Exchange. That's www.themotionexchange.com. That's a good place for motionographers, animators, everybody to network, get new clients, just chat, trade stories, trade demo reels, that type of thing. Check us out there. That's it for me. Again, I'm Chris Kirkman with aetutsplus.com, and we'll see you next time.